All right, we're going to jump right into Chapter 22 today. I'm not going to present anything different. We're just going to jump in and complete this problem. I apologize, it's a little bit lengthy of a story problem. Would being part of a support group that meets regularly help people who are wearing a nicotine patch actually quit smoking? So that's our big question. Here's what they did. A county health department tries an experiment using several hundred volunteers who were planning to use the patch to help them quit smoking. The subjects were randomly divided into two groups. People in group 1 were given the patch and attended weekly discussion meetings with counselors and others trying to quit. Okay, so that's a support group. So they have the patch and the group. People in group 2 also used the patch but did not participate in counseling groups. So we've got this comparison, right? Everybody's using the patch, but half of the people also have the support group. After 6 months, 46 of the 143 smokers in group 1, 30 of the 151 smokers in group 2 had successfully stopped smoking. Do these results suggest that such support groups could be an effective way to help people stop smoking? So what we've really got here is kind of two things going on. In group 1, I have this p hat. I'm going to put a little 1 as a subscript to help me remember this is for p hat 1. In group 1, 46 out of 143 stopped smoking. If I plug that in my calculator, that's 0.322. Awesome. 32% of people stopped smoking. And in group 2, I'm going to call this p hat with a little 2 to help me keep these straight because there are two proportions, two groups. This one, 30 out of 151 stopped smoking. That's 0.199. So almost 20%. So the question is, wow, group 1 was higher, right? Rock on. Is that just by chance, or did having that support group really help? Right? I mean, this result is higher than this one. So does that mean the group was helping? So we're going to do a hypothesis test to find out, did we see something different just by chance? Or is something really going on? Did that support group really make a difference? All right, so as you might imagine, this is a little different because now we have two proportions. But we're going to complete our hypothesis test in a very similar way. We're going to start out with step 1 by writing our hypotheses. So I'm just going to imagine for just a minute, I don't have some number value that is generic for people who stop smoking. But in the null, remember this is no difference. If the support group didn't help, then the proportion of people who quit smoking in group 1 would have to be equal to the proportion of people who quit smoking in group 2. Just ponder that for just a minute. If there was no difference between the groups, the proportion of people who quit smoking would be the same in both groups. All right, so that means alternatively, I'm going to compare these two. Well, if, remember, group 1 is the one with the support group, I think the support group helps more. So if we look back, the support groups could be an effective way to help people stop smoking. Does it help people? So that means I think more people in group 1 should stop smoking because they have that additional support. All right, this is a great way to start writing your hypotheses, but I'm going to encourage you to do just a little bit of algebra here and write your hypotheses this way. Oh my gosh, what did she do? I subtracted P2 from both sides. Because when we do these two proportion z-tests, what we're actually comparing is the difference in the groups. If you can keep that big picture in mind, that what we're actually computing is the difference in the proportions, that will make your life a lot easier. Okay, so keep that in mind. We're calculating the difference in proportions. So if the two groups are the same, when I subtract them, when I take their difference, I should get 0. And if the two groups are not the same, if group 1 with the patch is helping more, when I take their difference, I'm going to get a positive value. That's what that means, greater than 0, positive value. All right, so those are the hypotheses. The AP readers will take this or this. Again, if you can get in the habit of writing it with differences, that will help you in later steps, but either are acceptable because they are algebraically equivalent. All right, so in step 2, when we check conditions, hopefully by now we're starting to learn these conditions, we check for random. Now, it's okay to refer back to the story problem. It actually mentioned that let's see if I can spot it here. The subjects were randomly divided into 2 groups. So we do have randomization. That's great. That's what we're looking for. 2 groups were randomly assigned. Okay, we didn't like take all our best friends and put them in the support group. Okay, it's random. And then we're supposed to be checking that n is less than 10% of the population. Well, slight problem. We actually have 2 different n's. We have 2 sample sizes because we had 2 groups. So we're kind of going to mention this twice. One group had 143 people, and one group had 151. Well, both of these are less than 10% of all smokers. Sadly, there's a lot more than even 1,500 smokers. All right, and then, as you might imagine, we need to check our NP and NQ. They need to be greater than 10. 2 things to notice here. I don't have a hypothesized value for P, so I'm going to be using P hat as well as Q hat. You also might think to yourself, which P, right? Look back, we had 2 different P hats. So we're actually going to be checking this for P hat 1 and Q hat 1. We're also going to be checking this for P hat 2 and Q hat 2. Okay? Oh, and pardon me, that's equal to. All right, so for group 1, right, that's why I'm using these little 1 subscripts. This is for group 1. Before we get too carried away, I'm going to show you a shortcut. Just a second. But, okay, N for group 1 was, oh, I'm going to forget. Look at it. Here it was, 143, and there was the P hat, 0.322. Okay, 143 times 0.322. It should come out to be roughly 46. That number should look familiar. Here it is, right here. Okay. NP hat is the number of successes. Okay. In other words, it's the top number of your fraction. Just could be a time saver for you. Okay. So that's greater than or equal to 10. And if there were 143 people, I could just subtract to know that there were 97 who did not quit smoking. That's bigger than 10. So with group 2, let me take that little shortcut. It's going to be the number of successes, 30. So NP hat is 30. That's bigger than 10. So NQ hat, well, if there were 151 people total, that means there would be 121 people who did not quit smoking. That's greater than or equal to 10. If this bothers you, this kind of shortcut, that's fine. Just keep to what's familiar. That's okay. I just like to show you shortcuts for those who are interested. All right, so the conditions are checked. Notice I checked them for both groups. Okay, that's really important. Double the proportions. I'm kind of doubling the work on you. And we're going to complete what's called a 2-proportion z-test. Okay, again, you should always write that at the bottom of your conditions. What kind of test are you doing? Z, because we're still on a normal model. 2 proportions, because now I have 2 groups. All right, so we're on to step 3, mechanics. Step 1, we wrote our hypotheses. Step 2, we checked conditions. More than usual, I know. We're on to step 3, mechanics. In this situation, it's going to be really helpful to remember we're doing a difference. All right, P hat 1 minus P hat 2. It's a difference. So according to the null, the difference should be 0. The difference is supposed to be 0, according to the null. That's helpful for us, right? Because that tells us something about our normal model. It should be centered at 0. This value comes from the null hypothesis. Okay, we also need a standard deviation. It's going to be a little funky here. All right, so we'll come back to the slide. We need a new formula for standard deviation because we have 2 groups. So this formula is actually given to you on your formula page. Yay! So what we have here is the standard error. They call it standard error, again, because we're using estimates, of the difference. And it's basically we're doing, that looks like the formula for standard error for 1. And here's standard error for group 2, and we're adding them together. Because remember, variances always add. Okay? And again, that formula is given to you. But, small caveat, the problem is, according to our null hypothesis, right, null hypothesis, we actually think that the proportion in group 1 and the proportion in group 2 are the same. Okay, that's our null hypothesis. We believe they're equal. So if they're equal, we might as well just put them all together. And we call that pooled, like where you and your friends pool all your money together to buy something cool, maybe a pizza. So here is the formula for pooled. Okay, what do I mean by pooled? Okay, so p hat pooled means I'm going to take the successes in group 1, and I'm going to add the successes in group 2. And I'm going to divide that by the sample size in 1 and the sample size in 2. So in group 1, 46 people stopped smoking out of 143. And in group 2, 30 stopped smoking out of 151. So hopefully you see I'm just adding those 2 things together to give myself a p pooled value of 0.259. And this is the value I'm going to use in my formula here, where it says p hat pooled. Okay, so as if that wasn't disgusting enough, move this up just a little bit. So it's going to look like this. Square root of p hat pooled, we decided was 0.259. That means q hat pooled is 0.741. And notice this still says N1, sample size for group 1. Then I'm going to do it again. P hat pooled times q hat pooled over the sample size for group 2. And I'm just going to tell you this is a little bit of a beast to get into your calculator. You should practice. It is not fun. Do it anyway. Okay? When I do it, so you can check your answer. Okay, pause here. Type it in. Check your answer. I got 0.051. All right. So again, this is what we should be using in our hypothesis test. Gives us a standard error of 0.051. All right, so that lets me finish off my normal model. Okay, so here's my normal model. I believe that it's going to be centered at 0. And what did I observe? Because that's what the other thing I usually put on my model. What did I actually observe? Well, I saw p hat 1 minus p hat 2. I saw 0.322 minus 0.199 gives me 0.123. That's what I actually observed. So that's what I'm going to put in my picture, 0.123. Because remember, this picture is of the differences. Okay, that's why I'm using the difference. And my alternative hypothesis tells me which way to shade. I'm shading greater than. I'm shading greater than. And from here on out, it's a matter of calculating my z-score and then finding the shaded area. This part should be like a breeze for us from now. Okay, so notice I'm taking my observed, I'm subtracting the center, and I divide by that standard deviation we so horribly calculated. And I get a z-score of 2.41. If I put that in my calculator, it gives me the shaded region is 0.00798. Remember, this number is your p-value. All right, so we're pretty much home free. We just have to decide, what does that p-value tell us? Is that good, bad? So I did mention that we should always be using an alpha level, and of course, I am not perfect. I forgot to set an alpha level. So that's something I would do probably just underneath my hypotheses. If you forget like me, just go back and tuck it in. Let's pick an alpha level of, oh, I don't know, maybe 0.05. Real scientists choose this first, but we're just learning. All right, so based on my alpha level, my p-value is 0.00798. That is definitely smaller than my alpha level. Smaller when my p-value is low, reject HO. So I will reject the null hypothesis. Remember when I said in the null hypothesis that the two groups were equal? The same proportion of people were going to quit smoking with or without the support group? That's bogus. I toss it out the window. That means there is evidence that the support group has a higher proportion of people who stop smoking. What does that mean? That means for people who are using the nicotine patch, generally, they're going to be more successful. More of them, a higher proportion of them will stop smoking if they take part in a support group.